the meeting. Hello, everyone. So this line of series is going to be very technique agnostic, and it's going to be more in terms of principles, how to think about the problem, how to try to structure the problem, both when you are writing a new system and how to think about, and more importantly, when you're trying to manage an existing system. Because like 8 out of 10, what you will be doing is uh, working with an existing system. Um, and I had this discussion with my team some time ago, but I want to repeat for the people who probably missed it. Uh, I came up with a good analogy some time ago as to why is software so hard? Why is writing software so hard? Uh, does anyone have any theory based on what they know so far? Why do they think software, like solid software, is just really hard?
Because everybody else writes it poorly.
That would be one answer for sure. I completely agree. But why do people write it poorly?
Not able to
I think
think of all the
it's
scenarios
Uh,
beforehand.
let's go with Sushil. I want to ask everyone. So, Sushil, why don't you say why do you think software is?
no, I was talking on the same lines. I think of it in two aspects. One is estimation is the difficult part. Generally, it's people come up with timelines, but as compared to other fields, deadlines change more when it comes to software because it's just very dynamic. And secondly, the number of cases that someone needs to cover, and it's not even a case of uh, someone not being able to cover all the cases, but how do you in some scenarios it's just like how you want to not cover some cases and at the same time let the user know, like it's just managing the entire aspect of requirements, and how you execute that is a tricky part.
That's a good point about estimation and not having enough time. That definitely makes it challenging. Ritesh, you were saying?
Yeah, so my point was that beforehand, we may or may not be able to think about all the use cases of our system. Like only after
Mhm.
experiencing the system, we may analyze it. Okay, this was a new thing. So
Right.
not having clear requirements or clear use cases beforehand.
Okay. Fair. Todd?
So we're trying to solve real world problems, and the real world is infinitely complex and ever changing. And so you've got to model something that's, again, infinitely complex, and then model only and focus on a subset of that itself is also changing. So it's the complexity and the dynamic aspect of it that is like rarely well defined and understood.
That's a great point. I will touch on that. Mark?
So I also echo the sentiment about changing requirements. So I think that that's a big thing. And then I think the other thing is that a lot of the, I guess, functional design work is done in silo. And so you have one person's iteration of a specific idea, and how they execute that is very different from person to person. So I think that's a huge component. That's more of an implementation detail, but that's kind of what I think a lot of times big problems are.
Right. Okay. Irene?
So I have similar idea with Mark. So if you want to add some features to an existing system, you need to have the kind of similar ideas with those person who designed the system, but it's kind of very difficult to follow exactly what they thought. So yeah, it's a problem, I would think.
Right. Correct. Akshat?
I have similar thing. We go by many assumptions that everything will be fine, and we write code based on that instead of thinking what all things can break, like assuming things that they'll be good. And other point is like what Ritesh mentioned is like not knowing all the scenarios, not thinking about them.
Right.
If something changes, then the logic fails suddenly instead of handling
Right.
it.
Right. Okay, those are great points. So let me try to share from my side how, based on my experience, what I've been seeing, what are the challenges, right? One is every software that we write is brand new. It's not been written before, right? So it's not like we have a set of recipe that we can follow and just make this version of the software. So the classic example I like to talk about is, say, building of the bridges or building of the house, right? People are building house, but there is just a lot of material out there which tells you as to, hey, these are the things you need to think about, right? There is electric code, there is fire code, which sort of just tells you like, hey, these are the guidelines you better make sure you follow. These are the regulations to make sure that your house is going to be standing, your bridge is going to be standing. We have none of that, right? There is, for every software guideline that you can find in terms of to follow, you will find some exceptions to that, right? So we don't have any blueprint that we are, as a software developer, easy to follow and say, hey, if we follow this, then I think there is a high likelihood that our bridge will stay up and running for 100 years, right? Not that bridge doesn't fail, but bridge fails way less than, let's say, our software system, for example, right? So that's one. We don't really have any sort of blueprint. Two, and I really like that answer by Todd, is the problem we are trying to solve, especially that we are trying to solve, right? That is a line of business application. Our problems are sort of solving an ever moving real world business problem, right? So not only you have to solve the problem as and when you learn about it on the day one, but you also have to think about what's going to happen from a month, 2 month, 3 month, and how you will design the software, and how you would put together something is material to what's going to happen to that software in 3 months, right? And that is extremely challenging, right? Because if I give you a defined problem, right, it's fairly easy to write solid software which will solve that problem, right? So if I ask you to say, hey, write a program which will give me 5 digits up to n number, where n is the input, right? If I gave you that problem to solve to all of you guys, right, all of you guys will succeed and do it well, and that software will just run. But that's not what we are ever writing. We are writing what I like to call a living system. It's living, breathing, where it's just constantly changing. And that's where the challenge comes as to how do you design a software which you can also evolve as your business problem is evolving, right? And if you think about it, so, I've been working in hedge funds for a number of years, and I've been tasked to develop, say, trade master, security master. And every time I've gotten a chance to do it the second time, I have done it better. Because, based on the past experience, I know what are the things which are going to come, even if no one says that, oh, think about this. Right? And that is where experience in building software systems is very material, right? You can be, number one in topcoder.com solving any algorithm, but that will not mean anything as in developing a real living system, because the major chunk is thinking about how to evolve the system and not just solve the problem point in time. Does that make sense? Right? And then finally, and the thing that we're going to talk about in some detail is how to think about the failure modes of the system a bit more consciously. Okay, so what I have seen in all the code that I run into is people are not thinking in terms of the basic failure modes at all, right? And obviously, you can't think about all the failure cases, right? Because that's impossible. But I'm finding, based on the code that I see, is people are falling way short on thinking about the failure cases versus, say, being it somewhat in the middle. And again, that sort of also comes with practice, but some of them is just having that mindset. And my goal with this exercise, the problem that we are talking about, is to help you see that mindset. That how do you start looking at the failure modes more consciously? Hey, Sumil and Pavan, thanks for joining. We were just talking about how I just asked a question as to why writing a solid software is so hard. And then I think I covered this example with Sumil before, and it's my favorite example now. So Sumil has a household help, okay? His name is Chotu, okay? He's like a household help. And in the morning when Sumil wants a tea, right? He will just say, hey, Chotu, make me a tea, and he will get the tea, right? Now, how does that relate to software?
Can we pause for Todd's joke? I'm just waiting to listen because Todd's ready. I'm telling you.
All right, Todd.
Did you just give Todd so much fodder after this? It's not even funny.
It's okay.
All right, fine. Go ahead. Sumil and Chotu, I'm listening.
This is a really good example, okay? So bear with me, right? So you could get up in the morning and say, Chotu, go make me a tea. Now, here's the subtle thing about it when you think about it, right? He doesn't say to Chotu like, hey, go to the kitchen, open up the fridge, take out the milk, put the pot on the stove, let it boil to a certain extent, and then add some milk and then some tea and sugar, right? When you are dealing with humans, you are giving a very, very high level instruction, and that human is able to interpret that, and it works, right? So you can definitely imagine you can write a robot software which would be similar, saying, hey, when you get the command called make tea, hey, scoot into the kitchen, take out these things, time it to perfection, how long the water should be boiling, exactly after 1.5 minutes, add the water and make the tea and bring it back, right? But why don't we have that? Why don't we have that is because with humans, you can just give what I like to call happy path, and you don't have to worry about the failure paths, right? So the robot will work, but then one day, robot goes in the kitchen, opens up the milk, and milk has gone bad. Now, is the robot going to care that the milk is bad? No, he's going to still make the tea. It's going to be crappy tea, and Sumil is going to be pissed, like, what the heck is this, right? But without him telling anything about the bad milk to the person, that person will say, oh, milk has gone bad. And he will notify like, oh, milk has gone bad. I'm going to run, get the milk, and then fix the tea. Right? Think about all the, like, sugar is missing, right? All those things, you don't have to at all tell the human that if this happens, don't stop making tea. And how does it relate to program? The program you write, you say, if this is a perfect world, go do this. You don't tell the software anything at all. What happens if it's not the perfect world? And you have this 150 or, you have this lines of code, and that code just runs top to bottom, right? It's not able to account for any of the nuances which will come across. And it will just keep chugging along. And it will fail mysteriously. And then you are like, what the heck happened here? Does that make sense? Right? So that's the main challenge in terms of the software. Worrying about what I like to call the sad path, right? So I use the terminology happy path, sad path programming, that what you, not you as in, like what majority of developers focus on is the happy path in terms of writing system. They do not focus about the SAT path. And the more you think about, hey, what do I do when the SAT path happens, the more you will be able to design the system better, right? And what the system's behavior is when that thing happens, right? So for example, the problem that I just described about getting a daily financing accrual file, right? What would be, let's think about some failure cases that you guys can think of, right? We'll ask everyone to name one and we'll see how many we can get. So Mark, can you name one failure case for this problem that outlined would be there that one has to think about?
So this is getting a financial accrual file, you said? So if that file doesn't exist, would be the obvious one?
Okay, file doesn't exist, perfect. That's a very simple one. So I think everyone can agree that file doesn't exist is a fairly common one, right? Now, let's talk about what would your system respond with when that situation happens? What would you do, Mark?
Well, going with your analogy, if Samil said, go make me some tea, and there was no tea, they would come back and say, I can't make you any tea, or sorry, we don't have any tea. So with that, I guess my system would say, like, unable to find file, or file is not available.
Right. Now that's fine. Now the devil is in the detail here, right? When you say file is not there, what kind of error do you picture in your head to come up exactly?
If I was talking C#, it'd be a file not found, but it'd be a file not found exception. And I would have a personalized log statement there. And yes.
Okay, so let me actually join from my computer, and I'll try to show you something as to the first tenet of, let's say, when you are dealing with files, right, be it in an FTP system or be it in a regular system, how to think about it. Okay.
So
okay.
I think the other thing in this case is with the file, you're opening up something like a file stream of some sort. So you'd want to check to see if you have managed resources, and you can make sure that those are properly disposed of. But I would definitely try and throw an exception there and log what type of file is
yes.
the issue.
Yeah. But let's first talk about file not being found, right? So let's say you try to so this file doesn't exist, right? Whatever random path I just put in. Now, when I run this, can someone tell me what exception it's going to throw? It will throw file exception. That's given. But my more interesting question is it going to put this path, or is not going to put that path?
I think you'll see that path in the stack trace.
Okay, so Mark says you will sit in stack trace. Does anyone else have any other opinion as to whether we're going to see this path in the exception somewhere or not?
I don't know if it's going to spit out the path, but it will say that either if it's not there, it'll probably just say that not found. I don't think it actually throws the actual path out there. I'm not sure.
Okay. That's a cool point. So we have basically two choices here, right? Either it's going to say file not found, and it will say ctemp xyz.txt, or it will just say file not found and won't really say what path it is not found, right? So let's run it. So this one has definitely changed. It is now, they have improved this than what used to be better in the past. It includes the path. okay? And this is super helpful now. And sort of, I think if I had used an older API, actually it will not show you the path, right? And part of the reason that it will not show you the path is because of the security concerns, right? Because when your system throws an exception and it includes path sensitive detail, someone can use it as security vector to attack your system. That is why a lot of the libraries that you use, right, either .NET or some SFTP library or any sort of network operation, it will sort of not give you the detail as to what's missing. Right?
So full disclaimer, I recently dealt with this issue in the last 2 days, so that's how I knew that.
All right, that's good. It's all good.
Yeah.
All right, but so let's see. So when you were designing that thing, right? So we'll say, hey, you're gonna download the file, right? So we will somewhere try to connect to the SFTP, right? We will try to connect and then download the file, right? And save it in the local folder, right? And then we will, do some processing. At a high level, that would be what we were trying to do, right? And each of the steps could go wrong. And how your code will deal with each of those failures is what help you sort of build a better system. Now, so when I say resilient system, right, one thing to keep in mind is resilient system doesn't just mean that it doesn't fail, at least in my opinion. Maybe I need to think of a different terminology here. But resilient system in the sense when it fails, it tells you why it failed for you to recover it from it quickly. Right? And that's a sort of distinction to think about. In the sense, right, let's say you connect to the SFTP, right, and SFTP is not available. What's the error it's going to throw? Right? Most likely your SFTP library won't include any detail as to the server or the port number or the username that you were using. Right? And that would what makes it challenging when your job fails and you're like, oh, why did this job fail? Right? When you download the file, it might just say, hey, file is missing. And then you're like, oh, which server, which path that are you looking for? Especially for the SFTP, that will be very relevant, right? So let's say you will have something like SFTP server, let's say ftp.jpm.com, username as Adine, password as whatever, and then you sort of go into folder. They'll say, hey, go to this folder called outgoing and look for a file with a timestamp called YYYMMDD financing accrual.csv. Right? Now, if you, let's say, what I've seen, what would people write, right? They will write like, they will have some SFTP client, right? You put the server, username, password, right? You connect to it, right? And then you say, hey, download. So now then you construct a file path saying, hey, datekind.now.toString, YYY, and then dd.csv, right? So you will do it like, hey, I'm going slash, right? And then you will say, hey, download this path, right? And then, so this is, sorry, this will be like a remote path. Local path, you would say, hey, c:temp. Right, and same thing here, and then you will say, hey, this one, right? And then you will sort of return that local path for some further processing. Right, so there could be error here, right? And there could be error here, right? So how do you handle that, right? So if you just write this code, and which is the natural inclination to say, hey, let me just write this, right? And if the things are right, it will give me the relevant details. Then the code will work when things are good, but it will not give you the error handling that you care about, right? So the way to do this would be try to throw a more specific exception whenever you run into an error scenario. Okay, and try to add context, and that's all you need to do. So when you ask someone, hey, how do you do exception handling? How do you do error handling? Everyone talks about try catch, as if catching is the interesting part. Okay, because catching is not at all the interesting part. What is interesting is how are you throwing exception to add context to the situation is more interesting, because that's what the system will ultimately report. Okay, so the secret to writing high quality system is throwing as many exceptions as you can. Your code should be littered with throw statements everywhere. Anything you find off, you should throw an exception. Okay, so for example here, right, the way I would write sort of a helper class, and I would have like a catch statement, right, and I'll say throw new invalid operation exception, but I'll actually do like, hey, could not connect to the SFTP server, and put this the server name, username, and even the password. But in password, I will just sort of mask it a little bit. So it will be, error will be like, could not connect to FTP server JPM, ftpjpm.com using username XYZ, password. Okay, you put something, and then you just sort of do like this, you know, show some initial characters of the password. Right? Now, before I continue there on this one, like how many times have you run into something where you get this email error saying, hey, could not connect to FTP, but there's no context as to which FTP server it is connecting to? Has everyone run into that? And then you think about, okay, now where do I go? What do I do? Where do I even start? Because you've been writing this gazillion line of code, and suddenly it just says cannot connect to SFTP. But think if you did this. then you can go and search for ftp.jpm.com in your configuration file somewhere and try to figure out, oh, which particular FTP username I'm trying to connect to, right? You can open up the SFTP client yourself and say, hey, let me go and see actually if the SFTP is up or down. Right, and there, so let me again share my screen, right? So this is what I mean by error handling, is throw exceptions everywhere to add context to what the error scenario is. That's all. That's all there is. That's all it takes. I mean, not that's all it takes, but this is the big chunk of how you can write more resilient system, literally. Okay. Now, you might write this, right? But based on my experience, I would not write this, right? I would be like, hey, let's check if SFTP dot file. You can check remotely also if the file exists, right? So I will do this. If not, throw new invalid operation exception that file cannot be found, right? But I mean, to be honest, this one will throw the exception anyway. But what you can now do is throw a better exception saying could not find file remote path. Right, so now you will get error like could not find file outgoing /2020 0920 / financing accrual.csv. Right, so that's definitely more better improvement than before. Right, but you can actually take it a step further, right? So the way I would actually throw it is like this. You have all the details, right? So you can say this is a remote path, right? And you can create a variable called human-friendly remote path, which would look like this. XYZ, sorry, SFTP, XYZ at ftp.jpm.com /outgoing / right? You guys agree that you can construct this kind of path in the code itself? So when you don't find the path, this is the error you throw. You throw could not find daily stock financing accrual file. Expected remote file path is this. And now you get this in your email notification or your chat notification or whatever. And now it's simple, like, hey, everything is fine with SFTP, and somehow JPM hasn't really put the details of, they have not pushed out the financing accrual file, right? You don't have to go to the log file, you don't have to look at the code, because the code tells you exactly what it was looking for, and it has given you exact actionable information for you to take on. Does that make sense? So I'm guessing everyone has written FTP-based code, right? So how many wrote the code with this thought process? Like, how do I construct a better exception message when things are not the way I expect? Right? And that is all you need to start thinking, say, from today. Like, how do I throw a better exception when things are not there? And there, taking extra time and writing more code so that you can add more meaningful context to the error. Right? And that is what I often see missing when I look at the code reviews, that people are just not taking time to add as much context as possible. Right? So it takes, say, half an hour more, but you would be forever, like that half an hour once will save you that 15, 20 minutes of troubleshooting every single time. Right? How many times you run a system and it's like it downloads the file and then it's like, oh, this folder is not present, local folder. And you're like, just goddamn create the folder. Yeah, everyone has run into that, right? How many of you have a utility built in your library where you have a method called ensure directory for a file path? So that's one of my utility helper method. So whenever I need to save a file and I have already constructed a file path, I have a method that I call saying, hey, here's the path, just make sure the folder structure exists. Because I don't want to think about, hey, throwing that weird error saying this folder doesn't exist, when it's perfectly natural for me to just create that folder in the first place. Does that make sense? And finally, right, how can you sort of take it up further one level? Like when this happens, what do users generally do?
Send you an email
The next level
with
will
the
be to kind of
exact
make
fix.
these even more.
Sorry, Sushi, you were saying?
No, I was just saying from point of view of know what level of error it is, different levels of errors. And then, I mean, I've seen it in your code, so that's where my context is. And then if you have something which is critical, you use a certain level of logging, which gives you instantaneous information in email or whatever it is. And it has the exact thing that you need. I mean, that's what your philosophy is in general that I've seen, that I need to see the error if it's critical in my email, and the email should be concise and it should have the exact reason for that error from the application.
Right. So you will get this error, agreed, right? And this will be very meaningful. And not only can you receive this email yourself, but you can even include your end users in this email, saying, hey, this, if you format the error message right, saying, hey, could not find JPM daily stock loan financing approval, and put this URL, right? But then what do you do to recover from this, generally speaking? So you would, try to find somehow the JPM contact detail, right? And you will email them saying, hey, this is not there, what's going on, right? But then, instead of just creating configuration for SFTP only, you can also take in configuration the contact person when something is wrong with that SFTP. And then you can throw an error saying, hey, could not find this file, please contact person listed below, and you list down one or multiple contacts. And then you can just send this particular email directly to your business users, and you are done. and include some more instruction like when confirmed that the file is available, here's the path of the job to trigger. Right? So it's like from having to look at every technical failure on your own, you can literally make the system tell you what it was expecting, what is the recovery way to, how do you recover from it? And when you recover from it, this is the way you rerun the process so that it's done. And now you're out of that business completely in terms of managing that. Does that make sense? Right. So this example is dear to me because when I started at MIK in 2009, you were downloading all this FTP thing, right? And I was tired of looking at those things and just figuring out like, hey, why do I have to like, who is the contact at Morgan Stanley? I can never remember, right? And users get annoyed. I get frustrated because I feel like this is completely not problem on my system. It's like, there is no file. So I basically just added this so that email, I just gave it to the operations at Bridger Capital. And then they never bothered me about files. Right? And the goal is like, hey, as Todd articulated, right? The requirements are complex, things are changing, right? And other systems are not going to behave perfect. If your system can give a very meaningful context, what it will lead to is you will stop wasting time on trivial nonsense that happens in systems because of a variety of reasons. You know, your turnaround for any failure mode is 5 minutes versus 1 hour. It frees up your time in terms of writing more systems which are higher quality and deliver more value. Does that make sense? So I wanna take a pause here. We have already 45 minutes in, and I'm gonna just talk about, sort of take some comments as to any questions or comments on what I talked about so far. And have you written code like this, your past experience, if someone wants to chime in?
I mean, what you said makes sense. I just have one question. Would it be a right statement if I say, if I know exactly what to do in a situation of a possible error, I should use try catch. If not, I should throw? Because I've seen generally people sometimes overusing try catch, right? Like, and generally my understanding is if you know how to deal with the error, use try catch, otherwise don't. But even in even in some of those scenarios, a thought comes to mind that should you be using try catch over here or should you not be? So based on your experience, what are some general cases that you've seen of people using try catch at places where they shouldn't? And the first statement that I'm that if I know exactly how to handle the issue, I should use a try catch, and if not, is that true or not?
So that we will sort of cover in the next chapter in terms of specific try catch.
Okay.
Right?
Okay.
One
Okay.
thing you ever see, and majority of the code you will see, right, is like method. All the code is in try catch, and there's logger.error or something, and put the error.
Exactly.
Right?
Yeah.
That is complete garbage. Do not do that.
Yep. Yep.
That is not exception handling. Catching an exception and logging it is not exception handling. Not at all, not even close. So that I completely disagree with. As I mentioned, and this will sort of require, and I'm expecting questions on that front. Your job is to throw exceptions, not catch them.
So, JD, one of the things that I usually do is I'll throw the exceptions in the lower level functions. So I know that they exist, and then, you know, that'll be logged internally. And then what I generally try doing is in like the helper functions that go into like something like a controller, what I'll do is I will catch the exceptions that I know that I've raised there, and I will format that so I know what's being presented to the user versus what's being logged internally is different. Do you kind of approve of that approach, or do you think I should just pass everything on to the user?
So we will sort of get into that detail, right? And that is where one of the challenges, because I think people are fully not able to visualize the top to bottom execution to see what is the right level to catch, right?
Right.
And that is where people just, have you seen sometime that you get the same exception logged multiple times?
I
And
mean,
like you see,
yeah, the answer is yes. We've seen that.
right? And that is because, you don't think about, hey, how do I exactly propagate it correctly at the right level? So that sort of, we will get into that, how to think about that aspect. But in general, and unfortunately, it's more of an art than a science. So it will come with practice. But in general, just throw exceptions. Throw exceptions. Don't try to catch them. And we'll talk about where to catch them separately. But first thing would be, there should be extremely few places where you catch exceptions. There should be way more places where you are throwing exception. And when I say that, what I mean is if you catch and rethrow it right away, that is okay. I'm not opposed to that. Because sometimes the underlying library doesn't give you any choice but to catch the exception and then rethrow it for the context, right? So for example, for that SFTP example, if there was no method to check the file, then I have no choice but to wrap that download file method in a try catch and throw the exception.
Right. So
that is fine.
So in this case, what I often end up doing is printing out like the logging message, like you were saying, it's a vulnerability to kind of show like path information. And so what I'll do there is I'll catch it right before, I'll let it propagate through, I'll throw like the error, I'll do some logging. And then before it goes to the user, I will catch it and then say something along the lines of like missing file not found or something. And that's what will be returned.
Right.
So that's kind of the approach that I generally do is throw it down, but then have it filtered out in like the actual business logic.
Right. So as I said, we'll talk about in terms of how do you manage that chain and the exception propagation. So
I'm sure we'll probably end up talking about it tomorrow. but
any other question or comments on what we talked about so far?
One question I had was you spoke about like file input output and let's say that kind of exceptions. What about how to extend we should go about the data exceptions? Like if you know our treasury P&L reclass process, right? Like we actually logged, like if AUM data is also not available, throw an exception. And it took a lot of time to develop that code. So now it's like, should we really practice for the entire flow of program that we write, which could be more complex, and how like this data kind of exceptions?
And again, there you, as you highlighted, you just, every code you write, throw exceptions, be it in SQL, be it in C#, be it in Python. And the more you can find them out, the more you just throw them, right? And you will certainly hit some point where you can't think of any more cases or it's just too burdensome, right? But it will be some time before you get to that point, right? Just spending, say, 30% energy on throwing exception for the cases that hey, I need AUM before I can do something, or I need some security to be present before I can do something, right? Because you actually, when you're writing the code, you exactly know what your dependency is. You know you need data A, B, C before you can do something. And you write the code that uses A, B, C. But what you don't put in the code is ensuring that that precondition of ABC is actually valid or not. And what happens when program runs, right? And the worst case scenario is, because computers are extremely dumb, they just run the code. If something is missing, it just keeps chugging along. It just keeps chugging along. And
yeah, the point what I actually had more was, if you have a, let's say 10 data set records, let's say 10 portfolios, and one of them has a bad data, do we still write a program to stop doing everything, not even for other 9 portfolios which are good? Or, I mean, to what extent do we really go with that?
Yes, great point, right? That is, your first instinct should be to write to fail everything wholesale every time. That should be the default mode of operation. Let the user come back and say, you know what? I want system to separate out that handling. That is, hey, if 9 portfolios are good, continue with the 9 and let me know about the 1 separately. Completely fine, because sometimes, you know, you don't necessarily know whether it's meaningful that you exclude 1 portfolio, right? Because think about that someone is making some financing decision based on some numbers you are producing, right? In that case, it may not be okay that 1 portfolio is completely gone, right? There's a difference between him saying a 0 and saying something is wrong, I need to get correct data, versus seeing a number without 1 portfolio and making some trading decision based on that. Right? So having partial data available in case of data issues is strictly depending on the context of the problem you are trying to solve. Right? My default mode is no go. Right? Input has to be exactly the way system expect, and I will produce an output exactly the way I was asked to produce output, and nothing in between. But as soon as the system goes live, you will run into, oh, this happened. Then you tweak it so that it matches the user expectation while still producing valid data for the user. But that tweaking has to be done very carefully to ensure that you still get this behavior where when it fails, you know why it failed, what the recovery mode is, and so on and so forth. Make sense? Any other comment?
Yeah, so I'll, again, just comment in general. I worked with you at MIK, which was pretty helpful, and thankfully towards the end, I actually was able to borrow some of the stuff we discussed today, and I was able to pass it along to some people in the team when we started. Right now, my team's close to like 20 people, but when I started, it was like 3, and any additional time wasted, as you pointed out, you know, it definitely impacted efficiency. So one of the things I borrowed from you was adding more context and throwing. So I actually passed it on, and thankfully, a lot of the exceptions we have internally today are pretty specific. I mean, exceptions happen. It's not like they're going to magically disappear. Just that the time taken to troubleshoot it is a lot quicker than it was before. So that was definitely helpful. There are times when, as you pointed out, what's the next steps? It's cool at Bridger that you had emails that would go out automatically externally to the support person. We wanted to go down the path, but we wanted to be careful about how our piece of code worked first. So we emailed stuff internally. And then someone in OpsR or something would internally like forward it to the person, which is fine. We just wanted a second layer in case there are false positives. So we kind of had to evolve that way. And one of the things that keeps coming up with exception handling is also, where all do I capture it? Like before I started working with you, I would just log it to a file. But now you could log it to a file. You could capture it in a database. You could have it, I don't know, like 4 different places, right? Eventually, it also came to the point where business users, once they realized that we were logging all this in a database, they wanted us to run some stats on it to find out which kind of party was like screwing up more often. And we never thought this would be a use case for this data to come in handy. That was just for us to, you know, have it in SQL versus like, you know, sifting through like just raw text files. So that was again helpful. Not even intended, but it's just that me and my team came out as heroes after that. And I took the full credit saying that, of course, this was designed specifically for that. They don't need to know that. So that was good. The last point you brought about, JD, the one thing I will disagree there, not disagree, I mean, I think I am agreeing with you. The default mode of process everything or none, it doesn't always work. Now, it's a purist approach to take, but there's a lot of times when business dictates a lot of things. If I have obligations to a third party and I need to send some data out by, say, the 15th or 20th of a month, and I have to go with the best possible data I have at that point in time, which could just be 90% of the data or 95%, I still have to be able to provide that, make assumptions for the other 5%, and then work with it. I can't go to user and say that. I was like, well, I'm still going to give you pristine data, but you got to wait. So it's a very tricky situation there, being a purist versus what's practical. And that happens a lot, at least with me and my team. So yeah, just something we deal with.
So again, that's a very good point, right? About if you consciously write code what to do when you have 9 out of 10 and you have some logic for 1 out of 10, the error handling cases, that is fine, right? What I'm saying is, even for those individual 1 through 10 points, there could be some logic there also, right? How are you designing system to capture what you did, right? Bookkeeping, like what you talked about, that exception handling and finding out, right? One of the biggest thing that, we'll sort of go into this detail when we talk about this problem a little bit more, is how do you do bookkeeping in a database to help you give better answers, right? So we haven't even come to the parsing of the file and what do we do about that and all that, right? So we'll sort of go into that detail. And the main thing is just thinking about it very consciously. Every single step is where you will be able to find out, oh, what do I do here? What do I do there? And then build something that will be sort of just, it will run on its own for the most part. Right? Ritesh, any thoughts?
So when I started my journey in programming, this was fairly the first exercise that I did, to download a file and do stuff. So I fairly understand what all things want to work, but I don't really know how perfectly it works, but I have a fair idea of what not to do.
Okay. All right, cool. Unless anyone else has any other comments, we can keep it nice and tidy and call it a stop. All right. Looks like no other comments. Thanks, everyone.
What will we cover next week, JD?
We will go into how do you handle the actual system design, that is how do you handle the parsing of this file? Like,
Okay.
what are the error scenarios you can think of, and how do you recover from these error scenarios for the CSV file? Because CSV file is like bread and butter, right, for ourselves. Like, so how do you really handle CSVs? And then I'll want to go into specific about the question Mark asked. Like, if I'm saying to you guys, right, and that's the question I wanted everyone to ask me is, you're saying throw exception everywhere.
We'll catch it.
Who will catch it? How would like, that is the main question, right? That's the $1 million question. If you keep throwing exception, what happens to the system?
I wanted to ask that question. I didn't know how stupid that was. I just shut my mouth and I thought
No, it is not a stupid question at all. It is absolutely not a stupid question. I'm literally telling you, your job is to throw exceptions all the time, all the code. Just keep throwing exceptions. So if you're gonna just keep gonna throw exceptions, who's gonna catch it? How are you gonna recover from it? So we will sort of talk about that. Okay?
Okay.
Good.
All right. Great. Thanks, everyone. We'll see you next week.
Thanks, JD.
Thanks, JD.
Bye.